For my ENME351 final project, I've created a device that I like to call the Heated Body Identifying Targeting System, or HBITS. This device is made of an AMG 8831 thermal sensing module, as seen here, a diode laser, a stepper motor, a servo motor, various LEDs, a switch, 2 potentiometers, and a push button. This allows me to manually move the orientation of the motors to aim the thermal camera to change what the processing window is able to see. Additionally, I can switch it to automatic mode, where it will look for the hottest pixel on the screen and move itself accordingly in order to bring that pixel to the middle of the crosshair. Upon reaching that hottest point, the laser will actuate, so you will be able to tell in the real space where exactly it is that the hottest part is located at. If we take a look at manual mode, we can control the pitch and the yaw with the separate potentiometers. The stepper can be controlled with this one, and we can mess with the servo with this one here. As you can see, processing updates with the orientation of the camera and how it's facing. We can also, once we have found our target, activate the laser pointer to know where exactly it is that the crosshair is pointing to in the real space. Separately, we can press this button here to switch it to autonomous mode. In autonomous mode, it automatically searches for the hottest pixel in the 8x8 array that it can see, and it actuates the sensors, or the motors, until it finds that hot point, and then it activates the LED when it's satisfied with being close enough. As you can see, it's found my good friend Sam here, and is shining the laser on him to let me know that he is there. Back in manual mode, we can look at these 4 LEDs here, which tell us how far away from the hottest point the camera is currently facing. When it is red, it means it's as far away as it really can be, and by getting closer and moving towards the hottest point of the room, it slowly moves closer and closer to green. There, oh, it's a little, which at that point, you can use the laser to point out to your friends where it is. Oh yeah, that's probably good. One way we can better see the resolution of the heat sensing on here is with a small just pocket lighter. So without the lighter on, you can see the heat signature of my arm and my head. When we turn the lighter on, or ignite the flame, we can see the hot fire moving across the screen. In autonomous mode, we can see it slowly moves towards the lighter and finds it and actuates the laser. Within processing, there are a few key details. First off, we have the raw original camera data. The AMG 8831 reads an 8x8 pixel array of temperature values, which I import into processing and create RGB value color codes for through a series of piecewise functions that I experimentally calculated using MATLAB. Additionally, it calculates the hottest temperature visible at the moment and outputs what that temperature value is, as well as a corresponding color over here. So you can see further away I move, the cooler that gets. If I bring, say, the flame, for example, in front of the screen, you can see that it gets white hot. Slowly, more and more red and cooler as I move it further away. Now the larger image is an interpolated 64 by 64 pixel using bilinear interpolation from that original data. It's just a simple-ish algorithm that's used to guess what the in-between values would be in order to create a smooth gradient from pixel to pixel.